we've got a nice mixture in the audience of students, some academics, and health and fitness professionals. And as you'll be aware, this evening's speaker is Gary Taubes. I expect many of you will be familiar with his work. Gary will do a brief intro during his talk, so I'll keep this brief. Gary's an investigative science and health journalist and the author of some best-selling books in the nutrition space. His latest book is The Case for Keto. He's also written bestsellers Why We Get Fat and The Diet Delusion. And his writing has also appeared in numerous mainstream publications, including the New York Times Magazine and Esquire. I'm sure people will be joining us late, so just to fill in for a few minutes, I'll briefly explain how this webinar came about before handing over to Gary. My name's Paul Huff, and I've been working as a sport and exercise scientist and also lecturing in health and exercise science for just over 10 years or so. And prior to this, I worked in the fitness industry as a fitness instructor and personal trainer. And through working with many different clients, from people who just wanted to lose some body fat and improve their health right through to elite athletes, I became interested in the common goal of weight loss, and more specifically fat loss, and the best way to lose body fat. Often in academia, we kind of focus on peer-reviewed research, and rightly so, but I think wider reading and accruing knowledge through experience is also really important. During my research and my readings, I came across Gary's books, specifically Why We Get Fat and Good Calories, Bad Calories. And I found these books really interesting because they challenge the conventional dogma and theory as to why we gain body fat, which is based on the energy balance model. And I've put a simplified version of this on the slide. And this model just simply states that when energy intake exceeds energy expenditure, a state of positive energy balance occurs, and the excess energy is stored as body fat. And this is often known as calories in equals calories out. But as Gary will no doubt discuss, the equal sign, it doesn't suggest a direction of causality. In other words, what is actually causing or driving the energy imbalance? In his books and his scientific articles, Gary and his colleagues argue that the energy balance model doesn't provide a good explanation for the obesity epidemic, and in other words, the physiological mechanism as to why adults begin to accrue excess body fat. Gary and his colleagues have presented an alternative model called the carbohydrate-insulin model. I won't go into detail on this, as that's what Gary is going to be talking about during this session. But the basic premise is that eating processed high-glycemic load carbohydrates causes a dysregulation of the hormone insulin, which promotes fat storage, makes us hungrier, and lowers energy expenditure. I think I've got a fairly balanced perspective on this debate of the energy balance model versus the carbohydrate-insulin model debate. Gary's books really got me questioning the energy balance model, but on the other hand, one of a big critic of carbohydrate-insulin model is Alan Aragon, and he recently authored a chapter in the new edition of my textbook. And also, just through working with different clients over the years and being involved with a few different TV programs on diet, different types of diet, I began to see that the carbohydrate insulin model didn't necessarily align with what I've observed in many clients, but obviously that doesn't mean it's false. Gary will be able to correct me if I'm wrong, but I think what we agree on is that low carb diets are effective for decreasing body fat, but we differ on the mechanism of essentially what causes body fat gain, or the physiological causes. For example, someone who loses weight doing intermittent fasting, and you can correct me if I'm wrong here, Gary, but you'd probably argue that the main driver of that fat loss was a chronic reduction in insulin, whereas based on my limited understanding, I'd suggest the main driver was a reduction in total energy intake. So from my take on the research and experiences, I can see the benefits of a low carb diet. It's simple to follow, usually results in a unconscious reduction in total energy intake and tends to control hunger better than other diets such as low fat. A reduction in insulin and improved glucose control is probably or is likely a factor for the efficacy of low carbs, but I'm not quite sure if it's the sole driver. And before I hand over to Gary, because I often get this on Twitter and social media, just to be clear, I'm not against low carbohydrate diets. In fact, I recommend them, and I consider myself to eat a relatively low carb diet. And this often causes some confusion because people believe it doesn't make sense for me to question the carbohydrate-insulin model while advocating low carb diets. But as I said, I agree that they're effective for fat loss, but I'm a bit skeptical of the mechanism that Gary is going to discuss. Anyway, I've rambled on for too long. So without further ado, I will hand over to Gary.
Okay, thanks, Paul. Let me get my screen properly shared here. And now you guys should be seeing what I'm seeing. Yes?
Yep.
Okay, anyway, yeah, thanks for inviting me. What Paul didn't mention is that we had been arguing about this on Twitter. And I said, instead of arguing about it, how about let me present to your university? And Paul was kind enough to say, that's a good idea. Why don't we do that? So here we are. So let me just get started. I have a lot of ground to cover. And we're going to start with disclosures. I get book royalties. I get honoraria for talks, although I offered to do this one for free. I also follow a low-carb diet. So in this world, that's considered a bias. Context. I am actually, Paul and I are coming from a very different context in the sense that I'm interested in the cause of obesity primarily. So this is what the obesity epidemic looks like in the United States over the past 50 years. This is childhood obesity. Diabetes epidemic, which associates with obesity, is even more frightening because if you look at these numbers, we've basically, the prevalence of diabetes has increased about 700% over the past 60 years in the United States, which should terrify people. And we've seen these same kind of numbers worldwide. I like to use Margaret Chan, the former Director General of the World Health Organization, to make this point. In 2016, she gave a talk at the National Academy of Sciences annual meeting here in Washington, D.C., and it's a famous talk because she uses the phrase slow motion disaster to describe the increasing prevalence of obesity and diabetes worldwide. 600% increase in obesity, for instance. What's fascinating about this talk is in the talk, she gave an estimate for the likelihood that public health organizations like the World Health Organization would not curb these epidemics, not end these epidemics, but just prevent a bad situation from getting much worse. And her likelihood of this happening, her estimate was virtually zero. So one question you guys should be asking as you listen to this is, why are you hearing a talk from a journalist on a medical public health issue? And the answer is, in fact, when you have the Director General of the world's major health organization proclaiming, in effect, absolute faith that they will fail to curb the epidemics of obesity and diabetes, a likely question to ask, and a question I think everyone should be asking in this kind of situation, is maybe we've missed something. You know, when you fail to solve a problem, a likely explanation is you didn't understand the cause of the problem correctly. And it's interesting is there's effectively no interest in the medical community, or I've never seen interest in doing what I had to do as a journalist, I thought, to cover this issue, which is to go back in time and see if we missed something. So as that, I'm certainly the first journalist. A few others have done it after me, most notably Nina Teicholz. But I was effectively the only person to go back in time and ask a question, why might we have failed to solve this obesity diabetes issue? And just to give context, Hans Krebs, a Nobel laureate whose Krebs cycle probably drove you crazy in your biology, biochemistry classes, made this point. He said some students sometimes comment that because of the enormous amount of current knowledge they have to absorb, they have no time to read about the history of their field. But a knowledge of the historical development of a subject is often essential for a full understanding of its present-day situation. The way I saw it as a journalist when I started these investigations in the late 1990s was I had to understand the nature of the evidence that was being put forth as proof of things we supposedly knew, and in order to do that, I had to go back in time. And so, as a journalist, I effectively became a historian. So let's talk about this question: the etiology of obesity. Paul discussed this briefly. This is a conventional wisdom. Fundamental cause of obesity and overweight is an energy imbalance between calories consumed and calories expended. Okay, this is how it was phrased in a 2017 obesity pathogenesis review, an endocrine society scientific statement. From a thermodynamic perspective, it's clear that obesity is generally the consequence of small cumulative imbalances of energy intake and expenditure. You often see this phrase in the medical research literature: obesity is an energy balance disorder. As Paul said, calories in greater than calories out. The very short form of this is we overeat. The biblical terminology would be gluttony and sloth. So here's the hypothesis, basically the conventional hypothesis: too much food and too little physical activity leads to overeating, energy in greater than energy out. And the end result is obesity and the obesity epidemic. And what we're allowed to do in science, what you're supposed to do in science, is ask the simple question: is this right? It's treated as though it's sort of beyond question. It's always been considered obvious, not always, as I'll point out, but since 1930, it's been considered obvious. And it's a hypothesis, and we can ask the question: is it correct? And as a hypothesis, it has origins. And one of the things I think that propelled my research in this, I grew up in the physics community, and my first two books were about physics. My undergraduate degree is in physics. And in physics, you learn your science with the history attached. So you learn about Maxwell's equations when you're learning about electricity and magnetism, and you learn about the experiments that Maxwell did, and you learn about, when you learn about Einstein and relativity, you learn about what Einstein did, you learn about Eddington's experiments, observations in Africa to test Einstein's hypothesis. You learn what people believed, why they believed it, on what basis they changed their opinions. And in medicine, you learn nothing of this. So what I just gave you is, in effect, the central dogma of obesity that is caused by an energy imbalance. And I'm willing to bet that most of the folks listening to me, unless you've read my books, don't know the origin of this idea. So let's discuss it. It begins actually in the late 1860s. The birth of modern nutrition science is dated to German and Austrian researchers creating a device called a calorimeter, which could measure the energy expenditure of animals or humans, if this box here is big enough. And from the 1860s through the 1920s, all of nutrition research, for the most part, was vitamins and minerals, fiber, protein content of foods, and energy balance, because nutritionists could measure energy balance. In fact, it was one of the few things they could measure. They could measure the energy in foods using Bond calorimeters, and then they could measure the energy expenditure by the organisms that ate the foods. And by the early 19th century, throughout this period, during this period, two other developments. Max Rubner, the German biochemist, demonstrated that the laws of thermodynamics hold true for living organisms. And then two Americans, Atwater and Benedict, showed that thermodynamics also holds true for humans, and pioneered the science of calorimetry in the US. And then in the early 20th century, 1903, Karl von Noorden, who was a leading German diabetologist, put forth this idea that obesity was caused by an energy imbalance. There had always been this sort of general conception that people who suffered from obesity ate too much. You could find this in the medical textbooks, but von Noorden was the first one to give it a sort of scientific sound. He said, the ingestion of a quantity of food greater than that required by the body leads to an accumulation of fat and to obesity should the disproportion be continued over a considerable period. That, in effect, is the very first statement of what today is considered the obvious cause of obesity. And then Louis Newberg came along. Newberg was a University of Michigan physiologist. He had a checkered career. In 1929, he gave a talk in Boston at an American College of Physicians annual meeting, in which he claimed to have experimentally tested the idea that obesity was, whether or not it was a constitutional hormonal disorder, which we'll discuss, or an eating disorder, eating too much. And he concluded from his experiments, which were measurements of how quickly half a dozen obese patients lost weight compared to a single lean patient, not the voluminous experiment. He concluded that all obese persons are alike in one fundamental respect: they literally overeat. And he defined the cause as either perverted appetite, which is eating too much, or lessened outflow of energy, which is insufficient expenditure. He published 2 papers on this in 1930, and then another 3 or 4 papers through the early 1940s. He had a problem, though, with this theory. If you're going to say that obesity is caused by eating too much, you have to explain why people who are obese don't compensate by eating less or exercising more. And Newberg's explanation was they suffer from, quote, various human weaknesses such as overindulgence and ignorance. So one thing, if we had time, we could go into it more length. The idea that obesity is caused by an intake of calories greater than expenditure invariably leads to blaming obesity on a behavior and then having to explain why the behavior isn't corrected, and you end up with the kind of fat shaming that Newberg pioneered in this field, although other physicians at the time were perfectly willing to fat shame their subjects with obesity as well. So focus of attention post-Newberg is full body energy balance. Energy in is greater than energy out. The individual gets fatter. But the actual cause, where the problem ultimately lies post-Newberg, is in the head. So you take a physiological disorder in the gut, in the body, and you turn it into ignorance, self-indulgence, gluttony, and sloth. And physicians thought this was simple. I should point out, by the way, that when Newberg made this claim that obesity was surely an energy balance disorder, perverted appetite, the science of obesity constituted about a half a dozen to a dozen physicians scattered around the world, musing on the cause of obesity in their patients and taking patient histories from their clinical experience. There was no science of obesity the way we think of it today, and there was no way to experiment at the time. Clinical trials hadn't been pioneered yet, and there were at that time no animal models of obesity. So why was it considered simple? Well, we always had this vision of people like Falstaff, living large, eating and drinking large, and explaining their obesity. You see the association between somebody who eats a significant amount of food and drinks a lot and excess weight, and you assume that the eating and drinking causes the excess weight. And then there was this observation that if you starve individuals lean or obese, they will lose weight. And from that, it's assumed, therefore, and this is effectively what Newberg did in his experiments. And then from there, you make the assumption if people lose weight when they're starved, therefore they got overweight from eating too much to begin with. It's not actually, those two things don't actually logically follow. But when I was doing my research for my first book, The Diet Delusion, the leading researchers in the field of obesity throughout the second half of the 20th century also said the reason they believed this is because they knew that if they starved people, they would lose weight. So it's important in science to quantify the size of the effect that you're studying. This is always vitally important. And the size of the effect in obesity tells you something about the validity of this energy imbalance hypothesis. Here's the Centers for Disease Control, how they describe this. Weight management is all about balancing the number of calories you consume to the number of your calories your body uses or burns off. So we could ask a simple question. Let's assume, excuse me, let me move this, that as an adult, we have a patient where this is a given. We have a patient who's gained 20 pounds in a decade. Hey, that's not unusual for adults, 2 pounds a year. You simply ask the question, what we want to know is how much did they overeat, in a sense, to gain those 2 pounds a year, if we assume that overeating is the cause. And it's a very simple calculation. So a pound of fat is approximately 3,500 calories. And here's the mathematical equation: 2 years times 3,500 calories per pound of fat divided by 365 days will give us the amount of calories they've stored as fat per day. And the answer is 19.2 kilocalories per day, 20 calories per day. That's about the calories in 2 peanuts or 4 olives or 2 gummy bears. So it's 0.007, well, it's 0.7% positive energy imbalance. The obesity epidemic in America represents an average per capita weight gain of 30 pounds since 1960. That's an average weight gain of about half a pound per year. That's 5 kilocalories per day stored as fat. So what we're trying to explain is why the human body stores 5 calories a day as fat in excess and doesn't burn it, or stores 20 calories per day in excess or doesn't burn it. And that's out of, say, the 2,000, 3,000 calories per day that are being consumed. In fact, even if you assume that people eat, say, 300, 400 calories a day more than they need, you still have to explain why they might only store 5 calories a day as fat out of that 300 or 400 calorie excess. There's nothing new about this calculation. In 1936, actually, I found this in the 1924 version of this textbook. Eugene Dubois, who was a leading authority on metabolism in the United States, he wrote the seminal textbook, Basal Metabolism in Health and Disease, discussed this balance problem in the first paragraph of this chapter on obesity in this textbook. And he went through these same numbers that I just went through. And he said, considering that if somebody remains lean, they have to balance their intake to expenditure perfectly, because we know if they're off by just 20 calories a day, they'll go from being lean to obese in the course of 2 decades. He said there's no stranger phenomenon than the maintenance of constant body weight under marked variation in bodily activity and food consumption. And the question Dubois said, the one question we could ask is not, why do people get fat in a sort of food environment in which excess food is always available, but how does anyone stay lean? When you look at the day-to-day balance and you say, if I just store 10 calories or 20 calories too much, I'm destined to becoming obese. There has to be some other mechanism involved. So before Newberg came along, actually until the First World War, there was an alternative hypothesis I'm going to discuss. It vanished with the Second World War. And this hypothesis was that obesity was a constitutional disorder. And it was mostly a German-Austrian hypothesis. And the researchers discussing obesity in this era, when they got around to writing textbooks which had chapters on obesity, they would often include they would discuss all the reasons why they felt obesity had to be something other than an energy balance disorder. So one of the reasons was genetics. We know that obesity has a huge genetic component. It was estimated 80 to 90% in the 1920s. I think it's maybe 60, 70% today. These photos, which come from pre-World War II European textbooks, this is lean identical twins on the left and obese identical twins on the right. And the point of them using photos like this is they would say, well, what is it about our genes that determine not just how much fat we accumulate, but where the fat accumulates. We know that identical twins don't just have the same bodies, they have an effect, the same faces, they have an effect the same bodies and body types, and that body types run in families. So our energy balance hypothesis might tell us why these twins are obese and these twins are lean, these twins overeat, and these twins practice perfectly energy balance. But it tells us nothing about why the body fat accumulates in the same places in the same ways in the two twins. So one way or the other, we need some mechanism to understand adiposity that'll tell us not just about whether somebody has a BMI over 30, but where they accumulate excess fat, and then again, how much excess fat they accumulate. Animal husbandry was often cited as an example because we know we have animals that are bred to be fatter and thinner than others. And Edwin Astwood, who was the leading endocrinologist in the United States in early 1960s, he was at Tufts University, gave a talk making the point that I'm making today in his presidential address to the Endocrine Society. And he said, consider the pig, as corpulence and gluttony resulted from men's artificial selection. Selective breeding provided us with this hulk, with his hoggish ways, and no one will convince me that his gourmandizing was provoked by parental over-solicitude. The point being, when we see particularly fatty livestock, we don't think they got that way because they eat a lot, which they probably do, and certainly more than lean lines livestock. But we assume that something about the breeding process bred these animals to store more fat than lean animals. So the question is, what is it about that process? Sexual variations, again, photos from pre-World War II textbooks. Men get fat above the waist, women get fat below the waist. The question is, what regulates that? Even if both these people overate, consumed more fat, more calories than they expended, and to the point that they stored excess fat, why is it localized in different areas of the body? And a similar example of this, although not pre-World War II art, is puberty. And this was raised also by the pre-World War II physicians thinking about obesity. So boys and girls enter puberty with roughly the same amount of body fat on their bodies. They both grow over the development of puberty. They get heavier, they gain weight, they're taking in more calories than they expend. But boys will lose fat and gain muscle, and girls will gain fat in specific areas of their body, not everywhere. So the question is, we know that they're taking more calories than they expend because they're growing, they're getting bigger. But what determines whether or not the boys lose fat and gain, why the boys lose fat and gain muscle, and why the girls gain fat? By the time they get out of puberty, the girls have 50% more fat on their body than boys do. So you could think of puberty as, if not an obesogenic phenomenon to women, at least an adipogenic phenomenon. And yet the fact of them taking in more calories than they expend is just a given. We don't really care about that when we're trying to figure out what's determining these sexual differences, and it's clearly determined by sex hormones. So here's the ultimate problem, and Paul brought this up briefly. Energy balance is a tautology, it's not a hypothesis. So what I mean by that, for starters, the logic is circular. Okay, that tautological logic is circular logic, and it's logic that says the same thing in two different ways. So if you ask the question, why do we get fat? The answer is because we're overeating. If you ask the question, how do we know we're overeating? Because we can't actually measure energy intake or energy expenditure to the level of, the 10, 20, even 50 calories a day that constitute excess fat accumulation. So if you say, how do we know we're overeating? The answer is because we're getting fatter. And if you ask again, why are we getting fatter? The answer is because we're overeating. So what you have is a definition, is a description masquerading as an explanation. Think about this, remember this, the World Health Organization saying the fundamental cause of obesity and overweight is an energy imbalance between calories consumed and calories expended. Imagine if, rather than talking about obesity today, I was talking about wealth management. So you guys are going to go off into the world, you're going to make some money, you're going to want to secure enough to have a good life and retire comfortably. And you've brought me in to speak about wealth management. And we asked the question, how do I accumulate wealth, rather than how do I accumulate excess fat? And I told you that the World Economic Forum said the fundamental cause of wealth is a money imbalance between dollars earned and dollars spent. Dollars in greater than dollars out, and you get wealthy. In a field like economics, I hope you would be laughed out of the room if you posited the wealth imbalance hypothesis, or the money imbalance hypothesis of wealth. But in obesity, it became sort of conventional wisdom. In fact, to argue anything else is considered quackery. So where does this idea come from? And the answer is the first law of thermodynamics. Energy conservation, delta E is a change of energy in a system is equal to E in minus E out. So this is actually the one law of thermodynamics. It's easy to understand. The way we manipulate, so the change in energy in a system is equal to the energy in minus the energy out. And in obesity, exercise physiology, we assume that change in fat mass is equal to energy consumed minus energy expended. And then what happens with this theory? So what this theory says is the change of energy in a system is equal to, is the energy in minus the energy out. These two things are the same. Because energy is conserved, these two, E in minus E out, is just another way of saying that the energy in the system is changed. There's no arrow of causality here. And this is the point that Paul made in his introduction. It doesn't say that change in energy in a system is caused by a change in intake and expenditure. It says change in energy system is change in intake and expenditure. And what happened in the obesity world, for reasons that still mystify me and people still believe this, they insert an arrow of causality here and then they treat it like a law of physics, and it's not. In fact, I'm often accused of not understanding the laws of thermodynamics, and I have to say, excuse me, I think you're the one who doesn't understand them, because there is no arrow of causality here. All this says is the change in energy of a system is the same as the energy in minus the energy out. Just as the change in your bank account is the same as the money in minus the money out. So let's talk about the alternative hypothesis. I mentioned this in passing, that this was also a German Austrian hypothesis. So obesity, by this thinking, is a disorder of excess fat accumulation. This is first principles. This is going to bring us to the carbohydrate-insulin model, by the way, but we're starting on a broader level. So if you think of obesity just as a sort of excess fat accumulation, which is clearly what it is. So it's not, you don't say it's a disorder of energy balance or overeating or sedentary behavior. You just define what you're seeing, disorder of excess fat accumulation. In this case, gluttony and sloth are compensatory effects. They're not causes, and we'll discuss this. This is how it was phrased best. In all my reading, it was a character in a George Bernard Shaw play, Tarleton and Misalliance, who described this thinking best. He said, obesity is constitutional. No matter how little you eat, you put on flesh if you're made that way. It's sort of, if you want to put an arrow of causality into the first law of thermodynamics, the conventional wisdom says that changes in intake and expenditure cause changes in energy storage. This alternative constitutional hormonal hypothesis says that changes in energy storage, that the energy stored as fat is very well regulated. And if that changes, and that will have compensatory changes on intake and expenditure. If delta E goes up, if I have a drug I can give you that makes you fatter and your weight goes up, you will have to take in more energy than you expend because you have to create that energy from somewhere. Okay, so this is a German-Austrian hypothesis, pre-World War II. The two leading proponents were Gustav von Bergmann, who was a leading German authority in clinical medicine, internal medicine, pre-World War II, until 2010, the most prestigious honor of the German Society of Internal Medicine was a Gustav von Bergmann medal. He was no quack. And then Julius Bauer, who was at the University of Vienna in Austria at a time when the University of Vienna was one of the great universities in the world. Bauer was a pioneer in the field of constitutional medicine, which is more or less the application of genetics to endocrinology and chronic disease. This is how Bauer described the hypothesis in 1941. He said, like a malignant tumor or like the fetus. Actually, let me backtrack. I have to explain one word. They had to explain this local accumulation of fat that we discussed. Why is it men accumulate fat around the gut and women accumulate fat below the waist? There are places in our body where we don't accumulate fat at all, even if we grow obese, like our foreheads or the back of our hands. There's other areas that we do accumulate fat, and we all tend to be overly aware of those. They use von Bergmann and Bauer used the term lipophilia, to describe this, meaning love of fat. And that was the facility or characteristic of a tissue to readily expand with fat. So abnormal lipophilic tissue is tissue that gets fat easily, like the abdominal subcutaneous fat on a middle-aged man. Bauer said, like a malignant tumor, like the fetus, the uterus or the breast of a pregnant woman, the abnormal lipophilic tissue seizes on foodstuffs, even in the case of undernutrition. It maintains its stock and may increase it independent of the requirements of the organism. A sort of anarchy exists. The adipose tissue lives for itself and does not fit into precisely regulated management of the whole organism. A lipomatous subject may die of starvation and still remain lipomatous. So this is like Tarleton saying it's constitutional. Some people get fat, put on weight, no matter how little they eat. By the late 1930s, this theory was actually being accepted in the United States by many of the most influential obesity researchers. Russell Wilder was a leading expert on obesity and diabetes at the Mayo Clinic. He wrote an annual review on new science and nutrition through the 1930s. He said the effect after meals of withdrawing from the circulation even a little more fat than usual might well account both for the delayed sense of satiety and for the frequently abnormal taste for carbohydrate encountered in obese persons. A slight tendency in this direction would have a profound effect in the course of time. The hypothesis, he said, deserves attentive consideration. Hugo Roney, who was at the University of Northwestern University Medical School and wrote the first monograph on obesity in the English language literature in 1940. He described this theory as now more or less fully accepted, chiefly in Germany, by a number of leading investigators of metabolic diseases. So while Newberg through the 1930s was pushing this idea that obesity is caused by a perverted appetite and just eating too much, von Bergmann and Bauer's idea that it was a hormonal constitutional disorder was gaining significant interest. And then it died with the Second World War. This was one of the most fascinating aspects of my research. In 1938, Bauer fled Austria. He was an Austrian Jew, and when the Nazis invaded Austria, he fled to the US. He worked first at LSU for a year in Baton Rouge, Louisiana, and then he ended up moving out to Los Angeles, a move I can completely understand, and working at the Hospital for Medical Evangelists, where he ended his career sort of not being taken seriously. His 1941, when he got to the US, he realized that US physicians were taking Newberg's energy balance idea seriously, and he thought couldn't explain anything about obesity, as he had been writing in the German language literature. So he wrote an article in English that was published in the Archives of Internal Medicine, and he said the current energy theory of obesity, which considers only an imbalance between intake of food and expenditure, is unsatisfactory. It's the distribution of energy in the body too which counts, not alone the rough imbalance between intake and output. The adipose tissue is not merely a passive storing place for reserve fat, but a living and active part of the body with its own physiological and pathological processes. So this was a 20-page article. He spent the first 10 explaining why the energy theory of obesity, Newberg's, didn't explain anything about obesity. He said an increased appetite with a subsequent imbalance between intake and output of energy is a consequence of the abnormal Anlage. That's a German term meaning a sort of physiological predisposition rather than the cause of obesity. The following year, Newberg responded back in the early 1940s. This is like two bloggers arguing on Twitter. Bauer publishes a 20-page article saying Newberg's completely wrong. Newberg responds with a 60-page article in the same journal a year later, in which he dismisses von Bergman and Bauer's article in these two paragraphs. He says this is their suggestion that the fat cells of obese persons possess an abnormally great avidity for fat and exaggerated capacity for retaining it finds no support in experiments designed to test its validity. Body build is inherited, obesity is not. And this is the death of a paradigm right here. You could actually, I quantified the citations gathered by the article. So here's Bauer's article at the bottom, which received 10 citations total by 1959, and then vanished ever after. And Newberg's theory, perhaps because Newberg was the American and Bauer was not, or Newberg published second and Bauer published first, or Newberg published a 60-page article and Bauer only published a 20-page article. Newberg's articles on obesity were cited regularly through the end of the 1970s, at which time saying obesity was caused by eating too much no longer needed a citation to support it. So this is the death of the hormonal constitutional hypothesis. What's interesting is theories of obesity post-Newberg and John Brobeck, who was a Yale University researcher doing animal experiments, became theories of eating behavior, not fat accumulation. So just to explain that briefly, through the 1950s, the major theories on obesity were all trying to explain why people who suffer from obesity don't regulate their appetite such that they can perfectly balance their intake to expenditure. So there was a glucostatic theory published by Jean Mayer, the leading nutritionist at Harvard, claiming that the brain is monitoring glucose levels and that's somehow dysregulating obesity. There was a lipostatic theory published by Gordon Kennedy, who I think was at Cambridge, claiming that the brain is monitoring fatty acid levels in the blood. But the idea was there's some signal sent from the fat tissue to the brain, and the theories were explaining why the brain didn't adjust. Nobody is any longer studying fat accumulation. And the other interesting thing about this is beginning in the late 1930s, they finally have animal models of obesity. So obesity finally becomes an experimental science. And the animal models completely confirm the hormonal constitutional hypothesis. Jean Mayer, who, as I said, had this glucostatic theory in the 1950s, nonetheless studied a strain of obese animals. And as he put it, these mice will make fat out of their food under the most unlikely circumstances, even when half starved. So you have a theory of obesity that says that humans and animals get fat when they eat too much. And yet the experimental models of obesity, the animals would get fat even when they were half starved, even when eating too much wasn't an option. As Bauer put it in his statement, they get fat independent of the nutritional state of the animal, and they stay fat independent of the nutritional state of the animal. Some of the famous animal experiments, animal models, the Zucker rat, the Obi mouse, these are animals that would had been demonstrated in experiments you could starve them to death and they would die with more fat tissue on their bodies than lean animals. So if you just ask this question, if obesity is a sort of excess accumulation of fat, which on one level is the one thing we know for sure, if it's a hormonal regulatory disorder, which is now the assumption, the question is what regulates fat accumulation. This is how this question was asked in 1957 by Hilda Brooke, who was the leading authority in the United States on childhood obesity. She was another emigre from the German Austrian research community who set up the first pediatric obesity clinic at Columbia University. She said, looking at obesity without preconceived ideas, one would assume that the main trend of research should be directed towards an examination of abnormalities of the fat metabolism, since by definition, excessive accumulation of fat is the underlying abnormality. And then she added, it so happens that this is the area in which the least work has been done. What's interesting is in 1973, Brooke returned to this issue and pointed out by that time that most of this work had been done, and obesity researchers were still paying no attention to it. So understanding fat storage required a few innovations in measurement technology. In the 1930s, the ability to tag macronutrients in the diet with deuterium, a heavy form of hydrogen, so they could be followed around the body. In the 1950s, assay to measure fatty acid accumulation, fatty acid levels in the circulation. And in 1960, the ability to measure hormones accurately in the circulation. So until 1960, there was no way to do that. So if obesity was a hormonal disorder, the research community had no way to tell because they had no way to measure hormone levels. Insulin levels, the presence or absence of insulin was measured until 1960 by basically taking fat tissue from rats or mice and putting insulin into the media that you had the fat cells and seeing if the fat cells then took up glucose or not. By 1960, these technologies had all been developed, and by 1965, the sort of hormonal regulation of fat storage had been pretty much worked out. And this diagram is from the 2010 edition of Keith Frayn's Metabolic Regulation, a Human Perspective. Keith was an Oxford professor. He retired about 5 years ago. He was probably the leading authority at the time on metabolic regulation, but certainly the regulation of fat storage and fat metabolism. And what was learned by 1965, so the technology to measure hormones was invented by Rosalind Yalow and Solomon Burson. Yalow won the Nobel Prize for it after Burson had died. By 1965, they had established that insulin was a principal regulator of fat metabolism. So we think of insulin as working to facilitate glucose uptake and being deficient in diabetes when blood sugar levels are high. But what had been learned in the early 1960s, or from 1930s through 1960s, is insulin also worked to basically tell fat cells to take up fat and inhibited the release of fat from fat cells. So if you look at the forces determining fat storage and mobilization, they're dominated by insulin. It upregulates fat uptake, an enzyme called LPL. It upregulates the glucose necessary to esterify the fat. It inhibits lipolysis. Here's the inhibition. All hormones do something to fat mobilization. Adrenaline, noradrenaline, glucagon, they all tend to stimulate, try to get fat out of fat cells. Insulin is the only hormone that fundamentally works to put fat in fat cells and keep it there. Here's a suppression of fat mobilization, insulin, and insulin again. The way Yalow and Burson put it, the release of fatty acids from fat cells requires only the negative stimulus of insulin deficiency. So when you're actually studying the regulation of fat storage, like I said, virtually every hormone on some level tries to get fat out of fat cells because it's trying to tell the body to do something, flee, fight, grow, reproduce, and it makes the fuel available for those, wants to make the fuel available for those actions to occur. Insulin is a hormone of fuel partitioning. In effect, it orchestrates whether or not we store fuel, and it tells insulin to be stored while it's signaling the cells in the non-adipose tissue to burn glucose. So by the mid-1960s, Yalow and Burson had a simple hypothesis for obesity. We generally accept that obesity predisposes to diabetes, but does not mild diabetes predispose to obesity. Since insulin is a most lipogenic agent, that could have said the most lipogenic agent, chronic hyperinsulinism would favor the accumulation of body fat. So here's the key points of fat cell regulation. I've got about 5 more minutes in this talk. I think we're running a little late, for which I apologize. This is textbook medicine. When insulin is secreted or chronically elevated, fat accumulates in the fat tissue. This is textbook medicine. When insulin levels drop, fat escapes from the fat tissue and the fat depots shrink. And then we secrete insulin primarily in response to the carbohydrates in our diet, or at least to the glucose in our bloodstream, which comes primarily from the carbohydrates in our diet. So you put these 3 together, they're all in effect, like I said, textbook medicine, they're well accepted. In 2005, when I was writing The Diet Delusion, I asked George Cahill about this. Cahill had been the leading obesity diabetes researcher at Harvard in the 1960s. He had done some of the initial work on fat storage and metabolism. The 1970s, after the 1980s, became director of science for the Howard Hughes Medical Institute. So when I interviewed him in 2005 to see how much of the science was still sort of accepted, he said, yeah, carbohydrate is driving insulin, is driving fat. That's true. And so what's interesting about that is if you remove these words as driving insulin, you're left with the logical equivalent, which is that carbohydrate is driving fat. And you've gone from textbook medicine to quackery. One reason why I don't mention the word carbohydrate, well, there was one mention in passing, but until this late in the talk is because when I give this talk to medical schools, and I've given grand rounds a dozen times at least, the physicians tend to stay with me until I get to the word carbohydrate, and then they start to wonder if they've been bamboozled because they're obviously listening to a quack, because as soon as I say carbohydrate is driving fat, then obesity is not about energy imbalance. It's about some effect of carbohydrates being fattening. It's interesting to look at the textbooks, and you can do this yourself, and I recommend. In the US, the leading sort of biochemistry textbook is Leninger. This is, let's see, the latest edition. And if you look up fat accumulation in adipocytes, you'll see it says high blood glucose elicits the release of insulin, which speeds the uptake of glucose by tissues, favors the storage of fuels as glycogen and triglycerols, while inhibiting fatty acid mobilization in adipose tissue. So fat accumulates in fat cells because of high blood sugar, in effect, which comes from a carb-rich diet. If you look up what it says about obesity, it says to a first approximation, obesity is a result of taking in more calories in the diet than are expended by the body's fuel-consuming activities. So all I'm saying is somewhere along the line in the past century, the science of fat metabolism and fat storage was divorced from the science of obesity. So the science of obesity is a science of excess fat storage, and yet the mechanism by which we are assumed to store excess fat no longer has anything to do with the mechanisms that control the storage of fat itself. And people like me are making the argument that there's absolutely no excuse for, well, there is I can explain why it happened, and Newberg was the primary reason. But if you use this, if you assume that obese humans are made up of billions or trillions of obese fat cells, and then you use this as the explanation of fat cells, is why fat cells get fat, which is well accepted, then you have a different theory of obesity than we have today. So here's the alternative hypothesis. Like any growth defect, obesity is a hormonal regulatory disorder. Like type 2 diabetes, it's fundamentally a disorder of insulin signaling, hence diabetes. So we know type 2 diabetes and obesity are so closely associated that many people think of them as 2 sides to the same coin, because obesity, type 2 diabetes is a disorder of insulin resistance, and individuals who are insulin resistant are hypoinsulinemic. This is the point Yalow and Burson were making, then perhaps the hyperinsulinemia is causing the obesity, and because the insulin is responding to the carbohydrate content of the diet. It's triggered by the carbohydrate content of the diet. So this is sort of, the argument is, if you take into effect the physiological regulation of fat accumulation and fat metabolism, you're left with the hypothesis that targets the carbohydrate content of the diet as the prime mover. Not all carbs, okay? So this is an important point. Not green leafy vegetables, because they have actually a very low digestible carbohydrate content. High glycemic index carbs, bread, cereal, rice, and pasta. And sweets, sugars, because of the fructose content. So those would be the triggers in this alternative hypothesis. The explanation for the obesity epidemic is in part that in the 1980s, in the United States in particular, and then it spread around the world, we were told to make high glycemic index carbohydrates the bulk of our diet. And if you look at the data, we pretty much did. And sweets were given a free pass. We were so concerned that fat causes heart disease that the entire nation was put on a low-fat, high-carb diet, and obesity and diabetes rates, coincidentally or not, exploded. So here's the alternative hypothesis. Refined grains, starches, and particularly sugars cause a dysregulation of insulin signaling, and that causes excess fat accumulation, obesity, and the obesity epidemic, and also diabetes and the chronic diseases that associate with it. The implications. So today, the conventional wisdom, you'll find this in textbooks all the time, all diets at work, all diets that result in weight loss do so on one basis and one basis only. They reduce total calorie intake. And this would be the alternative hypothesis. All diets that result in weight loss do so on one basis and one basis only. They reduce circulating insulin, and they do so by restricting carbohydrates. Should any of this be surprising? And what was interesting to me in doing my research is that the conventional wisdom through the 1960s was that starchy foods, farinaceous and vegetable foods, as Tanner put in the practice of medicine, farination means starches are fattening and saccharine matters are especially so. Two British leading dietitians, this was writing in the British Journal of Nutrition in 1963. This was the first sentence in their article. Every woman knows that carbohydrates are fattening. This is a piece of common knowledge which few nutritionists would dispute. What's interesting is they went on to dispute it, but the question is maybe the women were right. When I looked for diets for obesity in the 1940s, 1950s, I found half a dozen that were published in the medical literature from Harvard Medical School, Cornell Medical School, Rush in Chicago, Stanford Medical School, some very good medical schools. And this from Raymond Green, who was the brother of Graham Greene, but more importantly, was the leading endocrinologist in the UK in the mid-20th century. In his seminal textbook, The Practice of Endocrinology, and the diets looked like this: foods to be avoided, bread and everything made with flour, cereals, including breakfast cereals, potatoes, all the root vegetables, foods containing much sugar, all sweets. And you could eat as much as you like of the following foods: meat, fish, birds, all green vegetables, eggs, dried or fresh, cheese, fruit, except bananas and grapes. With the exception of fruit, some of the fruit. This is basically the keto diet or Atkins circa 1950. And these other diets for obesity were saying pretty much the same thing. Some of them may or may not have also restricted high fat, butter, oils, excess fats. What's interesting is they didn't say that 10% or 15% or 20% of the diet should be carbohydrates, and we can eat 40% of saturated fats or meat products or vegetables. Foods to be avoided were foods that were considered fattening. Foods you could eat as much as you like of were foods that were not considered fattening. And this is the gist of this hypothesis. You don't eat these foods because they literally make you fat. They do it hypothetically, by raising insulin levels and causing fat to be stored and lipolysis to be inhibited in the fat cells. And you can eat as much as you want of these foods because they don't cause obesity. So it's a very simple hypothesis. It just doesn't include energy balance as anything other than a law of physics that everything has to follow. So here's the catch. This is one of the reasons why it got in trouble. And these are my last slides. You asked the question, why go so far? I could buy the idea that carbohydrates might be uniquely fattening, but why go so far as to tell people to eat a ketogenic diet, which I'm advising in my latest book many people do. And the question is a point that Yalow and Burson made in their research and has been consumed numerous times. To the mobilization of fat and fat cells is responding to what they call the negative signal of insulin deficiency. So as it turns out, fat cells are very sensitive to insulin. When I said prior to 1960, the way you measured the insulin action in blood to determine the status, for instance, of somebody with type 1 diabetes was to inject their serum into a petri dish with fat cells in it, because the fat cells were so exquisitely sensitive to insulin, they would respond where muscle cells might not. And so in the 1990, Ralph DeFranzo and his colleagues published a study of how fatty acid turnover, that's mobilization from the fat cells and oxidation, changes in response to insulin levels. And what you see here is insulin levels coming down from relatively high, over 200 units of plasma insulin, to lower and lower. And as insulin levels drop, the fat tissue doesn't really respond until, because it's so sensitive to the insulin that it's inhibiting lipolysis regardless. And then you get below a certain threshold, and suddenly the fat tissue starts to dump insulin, fatty acids into the circulation. Those fatty acids can be used for fuel. So the way DeFranzo, who invented the measuring technique that was necessary, the insulin clamp technique necessary to do these studies, he said insulin regulation of plasma-free fatty acid turnover oxidation is maximally manifested low physiologic plasma insulin concentrations. So what that means is there's basically a threshold beneath which fat cells have to, insulin has to get before the fat tissue respond by mobilizing fat. This is what Yalow and Burson called the negative signal of insulin deficiency. And that threshold is exceedingly low. And if you want to get somebody who suffers from obesity to mobilize their fat and be able to oxidize it for fuel without starving them, then you have to get them below this threshold. And the way you know they're below that threshold is, in effect, if you restrict all carbohydrates, all but the green leafy vegetables, and replace the carbs with fat, and now you're on a ketogenic diet. What's fascinating about this, and these last few slides, all of this science was worked out in the 1960s. It was worked out by people who either didn't care about obesity because they thought of their work as studying fat metabolism and fat storage, or it was studied by people who did care about obesity but thought about obesity in the terms of Newberg and sort of gluttony and sloth. When diet book doctors started reading this same literature in the 1960s and then crafting low carbohydrate ketogenic weight reduction regimens, and the most famous was Robert Atkins. They sold like hotcakes, to use a bad pun. Atkins' Diet Revolution was the best-selling book since the Bible when it came out in 1972. And the medical community responded in large part because Atkins was claiming that obesity wasn't about how much you ate, but about what you ate, which they saw as denying the existence of the laws of thermodynamics. And they didn't like the fact that these were high-fat diets, because this was a period in time we were coming to believe that dietary fat caused heart disease. And here Atkins was telling people to remove the carbohydrates and replace it with high-fat foods. So they published a critique of low-carbohydrate ketogenic weight reduction regimens in which they said fat is mobilized when insulin secretion diminishes, which is a science I've been talking about, excuse me, And yet low carbohydrate diets are bizarre concepts of nutrition that should not be promoted to the public as if they were established scientific principles. So when the American Medical Association decided they had to reject Atkins because he was promoting a high-fat diet at a period in time when we were beginning to think high-fat diets caused heart disease, they knew, the authors, two authors, knew that fat, if you want to get fat out of fat cells, you have to lower insulin, but diets that maximally lower insulin shouldn't be recommended, promoted to the public. So through the next decade, you see the the authorities, as obesity has finally become a subject of serious study, the NIH is funding it, and obesity researchers, because they don't want to give any credence to the arguments of people like Atkins, who might get people to eat high-fat diets, they throw out the baby, which is the hormonal, metabolic, physiologic regulation of fat tissue, with the bathwater, which was the diet book authors who were saying we got to pay attention to the baby if we want to listen. Last quick note. One reason I got into this when I first started writing about this in 2000, one of the first findings, 5 studies had been done testing low carb, high fat Atkins-like diets against the kind of low fat, low saturated fat diets low calorie diets that the American Heart Association was recommending. And all 5 found remarkably that these low carb, high fat diets actually improve not just weight loss, but heart disease risk factors. So this is a review from 2011. 17 clinical investigators, 1,140 obese subjects. In total, low carb diet is associated with significant decreases in body weight and body mass index, abdominal circumference, systolic blood pressure, diastolic blood pressure, plasma triglyceride, fasting plasma glucose, glycated hemoglobin, plasma insulin, plasma C-reactive proteins, and an increase in high-density lipoprotein cholesterol. The problem is low-density lipoprotein cholesterol. We've been taught that LDL is deadly. And even though this study didn't see any change, other studies see an increase in LDL, which is the singular focus of the heart disease cardiology community. Virta Health has been studying nutritional ketosis and individual type 2 diabetes. They now have about 5 years of data on follow-up. And I'm just going to go through these quickly because, again, putting patients with type 2 diabetes into nutritional ketosis using telemedicine and nutritional coaches to keep them there for years. And the gist of it is basically everything gets better when they put these patients. So A1C reduction improves, weight reduction improves dramatically, even when these patients are on the diet for type 2 diabetes, not for weight. They're not told to eat less. Prescription use drops dramatically. Okay, here's hemoglobin A1C drops, fasting glucose, insulin, home IR, any diabetes metabolic. Obesity decreases, obviously, triglycerides decrease, HDL increases, blood pressure comes down. Everything gets better on these diets, except LDL-C.